Let's talk about errors and tracebacks. Errors come in three forms. The kind that Python can detect before it even starts executing your program. Those are called syntax errors, and they're caused by having expressions that aren't formed well. The syntax of a language is its form, which requires that every opening parenthesis has a closing parenthesis, and that a plus sign has to come between two expressions. It can't come at the beginning. These kinds of things. The second variety is runtime errors. These are errors that are detected by the Python interpreter while your program is executing, and when those occur, you see a traceback, which is a report that describes what was going on in your program when the error occurred, and what line to look at in order to fix the error. And the third kind of error, a logical or behavior error, wouldn't be detected by Python at all. The program runs, it just does the wrong thing. The way to check for those is to write tests and check to see that those tests correctly describe the behavior of your program. So let's take a look at some of these and talk about how to interpret the traceback that is shown by Python when a runtime error occurs. So I'm going to write some code. Def of x returns some function g of x minus 1. And what is g? Well, how about it's a function that does something slightly more complicated. It calls another function h on y, and then it subtracts out the result of calling h on 1 divided by y. But here I'm going to introduce a syntax error. You're not allowed to divide times. You have to either divide or multiply. You can't do both. Okay, and then h of z, let's keep that simple. Just square z. Okay, then we'll print the result of calling f on 12 and see what we get. It should be the case that Python notices the mistake that I've made. And it does. It tells me what line of what file was incorrectly formatted, a syntax error. And it even shows me exactly where in the line that happened. That's what this little caret is. So I just delete that, and then my program will run. No, it didn't run. It says there's a syntax error on line 7. Syntax error, line 7 of my example.py file. And here's line 7, and it looks just fine to me. Actually, the problem is that I opened a parenthesis and never closed it up here. So Python was expecting that whatever appeared on this line was part of the abs expression that I had never finished. And you can't have a def in the middle of a call to abs. So sometimes when you see a syntax error, in fact the error is nearby. And this is just the first place that Python, the interpreter, was able to detect the error. That's what it tells you about. And now we're done. Well, now we're done with syntax errors. We've now encountered a type error, which is a kind of runtime error. And so we see a traceback for the first time. A traceback tells you what was happening in your program when the error was detected. The error that was detected is a type error, which usually occurs when you try to perform arithmetic on things that you cannot perform arithmetic on, things that aren't numbers. So in this case, we try to subtract something that's a none type and something that's a none type. Well, it turns out there's only one thing that's a none type, and that's the value none. This is the same error you'd get if you wrote none minus none. Except this one has a traceback that says it happened on line 1 of some mysterious file called stdin. This is normally read as standardin, but that's not an important topic for today. Here we got a much more useful traceback because we were running code within a file. It tells us which file, which line the error occurred in, but it also tells us what was in the process of being executed when this happened. So we were in G, the G function was being called, but it's also the case that the F function was being called and it hadn't completed yet. It was in the process of executing F's body, and this line in F's body, which said call g of x minus 1, when the error occurred. And in fact, that's not the only thing that was going on. Python was also trying to find the value of print f of 12. In order to do that, it had to evaluate f of 12, which means it had to call f, which means it had to call g which means it had to call h. And then once it had called h twice, it needed to subtract, and that's where the error happened. That's where Python noticed that something had gone wrong. Something had actually gone wrong before then, which was that h had returned none instead of the square of z because we never wrote return. So again, this is the position where the Python interpreter noticed a problem. That doesn't necessarily mean it's the line of code that needs to be updated to fix the problem. The problem might have occurred earlier and only been detected by Python at this point, which is the case here. But this is still useful output because it tells us where to look on line 5 of the file ex.py. And if we think about what might have caused none to be subtracted from none, well, it would be natural to look at h, and we found our problem. And now our program works. If we change the argument, now we have an error again. It tells us where it was. Oh, it turns out it's on that same line, but this time it's a different kind of error. A zero division error was caused by some division here. Well, it must be that one. Must be that we divided by 0. So in this case, the problem wasn't here. The problem was actually here, where we called f in the first place. We called it on an argument that eventually allowed us to divide by 0, which you can't do. So I'd say this is a useful starting point, but in this case it's quite helpful to have the rest of the traceback because you can see how we got to a y value of 0. Oh, it was from a x value of 1, which came from this original expression, which needs to be fixed. So that's a little bit about how to use a traceback in order to find the problem in your program. Perhaps that will help you debug something one day.